Hey, I want to do a brief introduction to limits, what they are and what they represent. So, a limit is denoted with the symbol L-I-M. As x approaches, we'll talk about what that means shortly, some value a of some function, in this case f of x, all right? That's the standard form for a limit. Now, let's take a look at one in practice. If we have a graph and our function, right, f of x equals 2x, all right? So at the value x equals 5, our y value will be equal to 10. So I'm going to make a rough sketch of this, all right? Let me move the dot over, all right? So, and let's say we're asked to take the limit as x approaches 5 of f of x. Now, f of x equals 2x, but let's not worry about that right now. And let's just say, what does it mean to take a limit? And what does it mean to approach? Well, to approach 5 means that we are taking values that get progressively closer and closer to 5. So an example for this might be 4, 4.5, 4.9, 4.99999, or from the right side, you might have 6, 5.5, 5.25, 5.00001, right? And I encourage you to take those values that I just said, put them into your calculator, multiply them by 2, and see what the end value gets progressively closer to. Now, if you do that, you'll see that our end value is getting progressively closer to 10, right? Because as our x values get closer and closer to 5, right? Let's look at it on the graph. It's getting closer to 5. We're getting closer and closer to 10 on the y-axis, right? So we can say that our limit as x approaches 5 of f of x, when f of x equals 2x, is equal to 10, all right? But let's throw in a little curveball. Let's say that this point is defined whenever f of x is 5, right? Then, no, whenever f of 5 is equal to 2, right? Does this actually change our limit at all? And the answer, I encourage you to think about that a little bit. Does it change our limit? The answer is no. Why is that? Well, it certainly changes our function, because when f of 5 equals 2, not 10, but we're not actually, with a limit, we're not working with 5 directly. We're working with values incredibly close to 5. So still, as we approach 5, we're not getting closer to 2, right? Because 2's down here. We're getting closer to 10. Okay? So how could we figure this out? Well, the easiest way to do it in this case is through direct substitution. You're not going to be able to do that all the time, but in this case, this is a very basic scenario. You can. You can just take f of x equals 2x. We're approaching 5. You substitute 5 in. 5 times 2 equals 10, right? That's the easiest way to do it. But let's look at something when you can't actually use direct substitution. So if we have some limit, I'm not going to graph this one out, but if we have a limit as x approaches 3 of x squared minus 9 over x minus 3. Well, let's try direct substitution. We put in x, we get 3 squared minus 9 over 3 minus 3, right? That equals 9 minus 9 over 3 minus 3, which is equal to 0 over 0. Now, whenever you see 0 over 0 like that, that doesn't mean you're done. That means it's in indeterminate form, and if you change the structure of the function, you can still find the limit. So how should we change the structure of this? Well, we can say that this is equal to, let's factor this out. Let's use difference of, or perfect square. These are both perfect squares, right? So this can be factored as x minus 3, x plus 3 over x minus 3. Then these two can cancel out, and we can do this completely algebraically, as you're seeing, and that just leaves x plus 3. So now we can actually use direct substitution. 3 plus 3 is equal to 6. So our limit as x approaches 3 of this is equal to 6. Now, a different rule that we could talk about, and if you're brand new to calculus, you don't need to know this, but L'Hopital's rule. What does that mean? It means we can take, when it's 0, 0, or it's in indeterminate form, we can take the derivative of both the top and the bottom, and then we can use direct substitution. So let's take the derivative of x squared minus 9. Well, the derivative of x squared is what? 2x. Then the derivative of negative 9, there's no change in negative 9, right? Derivatives measure change. Negative 9 doesn't have any change, so we can just disregard negative 9. With x, our derivative is 1, and then negative 3, there's no change. So we can just disregard that as well. Now this equals 2x. Let's use direct substitution again, and we get it equals 3. All right? So that was an easy way to do that. So let's take a look at 2 more examples. I want to take a look at limits as x approach infinity, very briefly. Now let's say we have the graph x equals y. All right, I know that's not perfect at all, but let's just say let's say this is x equals y. And what happens if we take the limit as x approaches infinity of this f of x? Well, as x gets larger and larger and larger, and it goes on and on forever, y grows proportionally with it, right? So as x approaches infinity, y is also going to infinity. Sorry for my sloppy infinities. Now, if I flipped this graph around, right, something to note is if it's like this, and my x approaches infinity, right? We're going on in this direction. Our y value is no longer approaching positive infinity because it's not going up, it's going down, so it's approaching negative infinity. Yes, there's a difference, and you have to specify whether it's approaching positive infinity or negative infinity. So in this case, we would say it's approaching negative infinity. Let's look at one more example with some horizontal asymptotes, right? Let's just say we have a graph that looks something like this, right? These are horizontal asymptotes. And let's say that these happen when y equals 2, right? And let's say that you are now asked to find the limit as x approaches infinity, right? What is that of f of x? This is f of x. Equals, well, what happens as x approaches infinity? X goes on and on forever, but right now y isn't actually going on and on forever. Well, it is, but it's not growing on and on forever. It's approaching a certain number, and in this case, that certain number is 2 because of the horizontal asymptote, right? So we would say that this is 2. Even though it's approaching infinity, we're still approaching a finite value, right? And then if we were to say in this case, approaching the limit as x approaches negative infinity, so now we're going on in this direction, we are approaching negative 2. Now, I hope you found this helpful. Thank you so much for watching. Let me know if you have anything to add or if I said anything wrong. Have a great day.